Hello everybody, welcome to today's class. Now in this class I shall discuss organic chemistry for the beginners, for those who are just starting organic chemistry. Now here in this class I shall discuss the classifications of organic compounds, which is already written in the board, that is how the organic compounds are classified. Now before going to this, let me show one thing. Let us consider this. What is this? Yes, it is the chain of dog. Yes, you are right. Something like this. This is simply a chain. Now, organic compounds also very often contain chain structure. That is, if we consider this and this, my two hands, that is here and here, carbon atoms will be there, and in the middle some carbon atoms will also be there. And here one important thing is that this end and this end are open. So this type of compound, rather this type of structures are called chain structures. Okay, and if this and this are joined together, maybe with one bond, then something like this will be obtained, and from this structure it is clear that this is a closed structure. So these are the two basic type of organic compounds are possible. So let me write down them first. So organic compounds basically may be classified into two categories, namely open chain and closed chain. Now look, closed chain may also be written as a ring. So since they have ring like structure, so they are called ring. Due to their cyclic nature are also called cyclic. So all these terms may be applicable for this category. Now open chain compounds, if we write down one example, maybe like this. So this is a compound which contains carbon 1, 2, 3, 4, 5 in a row, forming a chain. This is like a chain. So this is a open chain compound. Since this end and this end remains open, they are not attached to each other. So this end is open, this also open, forming this compound a open chain compound. Now come to this one, closed chain. So from the name it is clear that here the two ends will be attached. Now if we bring this one here, and form one bond in between, then what will happen? Let us write down this first. Let us write down this compound in this way. This is this end and this end is this one. Now if this loses one hydrogen, now what is the procedure to becoming from the previous one to this is not a matter of discussion here. We shall not discuss here this one, only we shall focus on the structure of this compound, and this is something like this. Look, if you are here, then you will never find one way to come out of this structure. So this is a closed chain or closed structure. Since this is looking like ring, this is called ring structure also. Since 5 carbon atoms are there, it is called pentane, and this is also pentane, but this is cyclic in nature, so this is called cyclopentane. So I hope it is clear to you, that is what is open chain structure and what is ring, closed or cyclic structure. Now this is not the end of this, because this type of compounds may be of different types. So these compounds may further be divided into basically two categories. Let me write down them. So these compounds may be divided basically into two types, alicyclic This name comes from aliphatic cyclic, that is any compound which is not aromatic, they are generally called aliphatic, and since they are cyclic in nature, so combining these two, the name comes aliphatic cyclic or collectively alicyclic, which is written here, and this one is aromatic. Now this is a very vast thing. Aromatic, aromaticity is a property, that is a compound to be aromatic some criteria should be fulfilled, but this is not the right place to go into this and to discuss everything about aromatic chemistry. Later on many more videos will come on aromatic compounds, so I am not just going in details right now. Alicyclic compound, what are the examples of alicyclic compound? Now if we write down the previous one, which already we have written, 5-membered ring and each corner contains carbon atom, so this is one example of alicyclic compound. Here it is cyclopentane. Now aromatic compounds. Aromatic compounds, most simple and most important example will be benzene. In class 10 you must have read this one, that is benzene, and simple molecular formula is C6H6, and if it is written in structure then it will be like this. So aromatic compound, benzene is one of the examples of aromatic compound. Remember one thing, in lower classes very often it is told that aromatic compound means benzene, but this is not the right explanation. Benzene is one of the most important examples of aromatic compounds, no doubt about this one, but benzene is not everything about aromatic compounds. Okay, now come to this one first. Alicyclic compound may further be divided into two basic categories, and they are homocyclic and another one is heterocyclic. Do you know the meaning of homo? Homo means same. Any chain or any ring which contains same atom. Here same atom is the carbon atom, everywhere carbon is there. So if this type of ring is there where each and every corner contains the same atom, that is atom of same element, rather here carbon, so this is called homo, means same, and cyclic due to the cyclic nature of this compound. And come to this one, this is hetero. Hetero literally means just the opposite of homo. Homo means same, so hetero means different. That is, in this case, if we write down this structure replacing one atom from here by any other atom other than carbon, it will become heteroatom like this. If we put one oxygen here, the rest thing remaining the same, then this, due to the presence of different atom here, the ring is now called heterocycle, or the compound will be heterocyclic in nature. So this is one example of heterocyclic compound. Now many more examples are possible. If you go through your book, maybe your textbook, maybe your reference book, you will find a lot of examples there. Now come to aromatic. Now aromatic compounds may be classified into three basic categories: benzenoid, then non-benzenoid, and heterocyclic aromatic. Now let me discuss one after one. Benzenoid, that is any compound which is aromatic in nature and which will be constituted by benzene ring. Most common example is benzene itself. So this is one benzenoid type of aromatic compound. Now if any hydrogen from here. Now remember one thing, each and every carbon contains hydrogen. If we replace any hydrogen by any other atom, forming so many compounds, and each and every compound will be of benzenoid. Let us consider this one. We may write down here OH, maybe this one is CH3, something else maybe there also, whatever may be the case. If it contains benzene ring or benzene ring like structure, then it will be benzenoid. Another common example will be like this: two benzene rings are fused together. So this one also contains alternate double bond, single bond. So this is also one benzenoid type of aromatic compound, since this portion is one benzene ring and this is another benzene ring. So these and many more to come, all these are aromatic compounds which are benzene like, so they are called benzenoid in nature. Now come to this one, which is non-benzenoid. From the name it is clear that they will be benzene like structure. No, they will not be benzene like structure. So let us consider a 7-membered ring. 1, 2, 3, 4, 5, 6 and 7. Now if this carbon contains one double bond in this way, to make it aromatic, something like this will be there. This is not clearly not benzene ring, but this is aromatic compound. This is cyclic again. So this is aromatic compound which is not benzene like. So this is non-benzenoid. Okay, and name of this compound is tropon. This is heterocyclic aromatic. Heterocyclic means cycle which is containing one atom other than carbon atom. Let us consider this type of structure. One nitrogen will be there. Now if we write down this compound, this is one aromatic compound, one atom other than carbon is here. So this compound is hetero, atom containing ring structure. So this is heterocyclic aromatic compound. This is aromatic, so aromatic. This is containing one hetero atom, so this is hetero, and due to the presence of cyclic structure, this is cyclic. So in this way we can divide the organic compounds in different ways. Now this is just the beginning, many more to come. In course of time you will find so many type of compounds and you will be able to familiar with so many examples from all these things. But since you are starting organic chemistry, if you have seen this video from the very beginning, now remember one thing, please don't consider this is everything. Now if you follow the lecture from the very beginning and then if you read your book properly, then combining these two you will have clear idea about the classification of aromatic compounds, maybe classification of organic compounds. If you find any interest in this video, then please subscribe this channel in order to get the notification of my upcoming videos. So that's all for today. Bye bye.